In this video, we are going to review finding the linear regression equation. We're going to talk about how to interpret the slope, how to interpret the y-intercept, and how to find the correlation coefficient, which is your R, and how to get that onto the calculator, because we definitely do not want to calculate that by hand with our geometry students. I have taken problem number 2 in lesson 1, and I've put the proteins in protein grams in L1 and fat grams in L2, just to speed it up a little bit. To get our regression equation, we're going to go to Stat, Calculate, right arrow, and number 4 is linear regression. We can just type number 4. If L1 and L2 do not appear, we can input those by hitting the second number 1 and second number 2. Remember, frequency list stays blank because each point is on there one time. And we want to store this equation in Y1. So we're going to go alpha F4 for the shortcut and enter so that we get Y1. Now, if the students are using a TI-83 or have not got an updated operating system, remember they can go through vars, go to Y vars, and function and pick Y1. So that was vars, Y vars, function, and pick Y1. And then we will calculate, get the equation, and we have a slope of 1.13 and a y-intercept of negative 1.4 or negative 1.39. Looks like a great equation. And remember that now is in here out to lots of decimal places we didn't have to put in, and ready to go to interpret values. Now, there's a few other things. One of the things that you want to see is you want to see an R equal. That is your correlation. Now, obviously, my diagnostics were turned off so that I can show you how to turn them on. So how do we do that? Well, we are going to go into our catalog. Notice the word catalog is above 0. So we're going to go second, catalog. And we're going to scroll down until we see diagnostics on. So we have a diagnostics off and a diagnostics on. And we want our diagnostics to be turned on. And you have to hit enter twice so that it says the word done for that to happen. Okay, now let's redo that linear regression and let me show you the difference. Oops. And number 4, we're going to pick that Y1. Probably would not matter because we've just done the same regression. Okay, notice on this one now, we see R squared and R. These have to do with statistical analysis. R squared is something they'll learn in AP statistics, but R is the value for the correlation. So their correlation would be 0.98, and that means a very strong correlation. Your correlation goes between -1 when it's absolutely an exact line with a -1 slope or a negative slope, +1 when it's all dots lined it perfectly up in a line and a positive slope, and 0 there's no pattern whatsoever. So the closer it gets to +1, we know the closer the dots are to being on that line. And if we look at the graph, we're going to hit zoom 9. Notice the dots are pretty close to that graph. So we could say a moderately strong relationship. So let's type in a couple of descriptions. So one of these is if I want to interpret the slope, I would type our remember our slope equation. If we go back to our we can go to y equal. So 1.13. So we would say for each gram for each 1 gram, increase in protein, there is an approximate 1.13, notice my slope, increase in grams of fat. Okay, AP statistics and defining slope is a little bit different. Instead of saying rise over run, it's saying as I run 1 unit, 1 gram increase in protein, then I will increase the Y 1.13. So it's worded a little bit different. Okay, and if I want to interpret the y-intercept, I would say a sample, and these don't have to be perfect, but when protein equals 0 grams, the predicted grams of fat is approximately negative 1.39. Now, you'll find that many times when you interpret the y-intercept, it does not make sense. Like, for example, at 0 years of birth, the child would weigh negative amount. Well, obviously a child cannot weigh negative, and that's okay. And they'll ask sometimes, does that make sense? And we would say, no, it does not make sense. So the other interpretation is that correlation. And that is your R. And we found R, I think it was 0.98. So we would say R equals 0.98, which means there is a strong, obviously 0.98 is pretty strong, positive linear relationship between grams of fat and grams of protein. Okay, I hope these finding R on the calculator. Now again, you have to turn on that diagnostics, and when you run that linear regression, it'll just show up, and just have your students ignore that R squared and look at R to decide if it lets me know if it's positive. The closer it is to 1 lets me know it's linear and its strength.